So we can really break up what we've talked about here into three different segments. The first one is multiple access, which looks at different ways that you can allow multiple people to share at the same network medium without causing interference to one another, or ways in which we can share the air. And we've seen how sharing is very hard because these were not easy to come up with, especially at the time. The first one's FDMA, frequency division multiple access, where we have division onto different frequency bands, and that was used between 0G and 1G. The second one was TDMA, which adds onto FDMA and also divides users in different times, and it adds capacity improvements over FDMA. That came about with the emergence of digital cellular and was popular 2G standard. Then we had CDMA, code division multiple access, where every link gets a different code, and that's how they communicate and know what's meant for them. And we didn't talk about this, but OFDMA, or Orthogonal Frequency Division Multiple Access, is the standard that's being rolled out for 4G LTE. And in a future course, maybe we'll come back and talk about the new and exciting ingredients there. And then we talked about interference management, especially under a CDMA system. When users are all talking at the same times and on the same frequency bands, how do we manage the interference that's caused there? So we talked about one first, which is the transmit power control, that simple one-step algorithm where we're adjusting for signal power rather than signal quality. Distributed power control was the meat of this lecture and what we looked at, and we saw how distributed power control overcomes the near-far problem, and that's caused with interference. And then some major themes. The first one is the idea of negative feedback, especially in distributed power control. We'll see negative feedback come up many times, but the idea is that you want to keep something at a constant level, like the SIR here, so you will adjust and decrease and increase your transfer power accordingly to make that happen. We also looked at negative externality, which is what negative feedback helps transmitters to internalize the negative effect they impose on the rest of the network. And we looked at distributed computation, which is another huge theme here, how DPC is completely distributed in the sense that each device can make its own decisions without having to know what the other devices are doing. And each device also performs its own computation, rather than having to do that computation in some centralized server. All right, so hope you enjoyed the lecture. We'll see you in the next one, which will be on Wi-Fi.